This video is going to introduce a settling tube apparatus developed by Physical Geography and Environmental Change in the University of Basel. This apparatus is used to fractionate the soil sample by settling velocity. The settling tube apparatus consists of 4 components: the settling tube, through which the soil sample settles; the injection device, by which the soil sample is introduced into the tube; the turntable, within which the fractionated subsamples are collected; the control panel, which allows the operator to control the rotational speed and rest intervals of the turntable. Before experiment, we first need to set the intervals of the turntable. As a demonstration here, we show you how the turntable rotates and rests over equal time intervals. To prepare the soil sample, we need a weight scale, a squeeze bottle, a 100 ml graduated cylinder, a funnel, a spoon, and the injection device. In this demo, we took 25 gram dry soil and wet it with 40 ml tap water and let it slake for 15 minutes. During the time, let's have a look at the injection device. It has a chamber and the metal rod. The metal rod has a Teflon cone that can be removed on and off at one end, a Teflon piston in the middle, and the rubber plug at the other end. When the soil sample is ready, it needs 2 operators to transfer the sample into the chamber. It's very important that one operator needs to hold the metal rod together with the chamber to keep it not falling off. The other operator can use the squeeze bottle to wash the sample into the chamber. The net volume of the chamber is only 80 cubic centimeter, so please watch out not to get it overflow. After transfer, re-screw the cone back and spread grease onto the conical-shaped face of the chamber. Then turn the whole injection device upside down at its working condition. In order to make sure the chamber and the top of the settling tube is air-tightened, it's better to rotate the injection device back and forth for a couple of times. Now the settling tube is sealed on the top, so we can lift up the tube and release the foamed rubber that is previously placed beneath the tube to keep the water column stand still. Rotate the turntable to place the first settling dish right beneath the settling tube. It's time to start the experiment now. Push down the metal rod into the tube and at the same time start the stopwatch. The soil sample is then released into the water and falls through the water column by different settling velocities, which depends on the size, density, shape of the fractions. The fractions are collected into the dishes over predetermined time intervals. By different time intervals, the amount of subsamples collected by each dish will change. The minimum time intervals is only restricted by the minimum subsample amount that is required to perform the analysis afterwards. After 10 minutes, larger fractions have settled through the water column. Only 5 fractions are left in suspensions in the tube. In this demo, we set the total settling time as 1 hour, so now it's time to restore the sampling dishes. First, slightly incline the sampling dishes to get rid of the extra water, and then slowly withdraw it out of the water tank. Repeat this action until the last sampling dish is taken out. In order to not disturb the fractions, we must be very gentle and steady. Now we need to drain all the suspension in the tube into a big container and treat it as one subsample. You can measure the properties of these fractionated subsamples. For instance, the weight of each class, carbon distribution across different classes, or grain size composition. If the whole soil sample or sediment generated from erosion events, then we can use the carbon content in subsamples to predict the redistribution of eroded carbon within a small watershed. Thank you very much for your attention.